I actually want to go back real quick to a little repeat zone. Right? Reason why is because last time I showed you a little bit of how to use it, but I want to show you an example, for example, what you can do with it as well. Right? Because it is a lot of fun to use. I've been working with it for the past week in between of these classes, and there's something that, well, you should know, right? Something that is incredibly important, something that helped me reduce the crashes of my Blender when you're using repeat zones. And it's something that is quite an easy fix, but um, quite important. So let's go to the geometry nodes, and I'm gonna delete this cube in the geometry nodes, right? So just don't actually delete it, but just disconnect it. There we go. And now let's add a quick little curve. Shift A, quadratic Bezier. And we can connect that up. And we can set all the values to 0 for a second. There we go. And I just want the middle points of this curve to be at 1 meters and the ends at 2 in the Z direction. And let's just move this middle points a little bit to the side. There we go. All right, and the top perhaps as well. Oh, sorry, the top. There we go. And if you want to rotate this around, for example, right? If you want this to, well, let's say we want to make a little kind of grass patch with this, or like a kind of branch for Halloween, some kind of weird looking tree, I guess. It's not really a tree, but more of like a branch sticking out. We can repeat this curve with Shift A, and we can search for a repeat zone, of course. Connect this up. Last time I think I only showed you this with an actual cube or some basic geometry. With a curve, it's a little bit different, and I'll show you why. So if we repeat this with a transform node in between, and Shift A join geometry node here, and connect the two up, I'm gonna drag my view to the bottom a little bit and set this to spreadsheet. This is something I now have with me at all times when I'm working with repeat zones. And there's a simple reason. If I rotate this a little bit in the Z direction and I up the iterations, right, you can see that with each iteration, my points are getting doubled, right? And that should not happen. They do have to add like 1 spline, 2 spline, 3 spline. That should be the points of 3 splines. But right now they're doubling every single iteration I do, which means that it's going to duplicate all this geometry in the same location and add 1 more spline, right? So if I set this to 12 iterations, we already have 70,000 control points for this little patch of splines. All right. So that is something that is definitely not what we want. All right. So how do we fix that? Well, it is quite easy once you know the quick fix, basically. All right. So what I'm going to do is just hit Shift A, and I'm going to look for a curve to mesh. All right. Curve to mesh. And I'm just going to make a little setup here. Curve to mesh. And I'm going to transfer this back to a curve. Mesh to curve. Reason why is because all we want to do is use one node, and that is the merge by distance, right? So any overlapping points that we have here, I want to be gone. So we're going to merge everything that is on top of itself. So hit Shift A, delete geometry, or sorry, merge by distance is what I mean. There we go. And this is the value that we need as well. Beautiful. So this is what I want to have in between my repeat zone at the end, right? So the reason why I'm not doing it next to the repeat zone, so after the output, is because it is still going to calculate all the points first and then merge by distance. But that is still going to take all this calculation time to make 70,000 points and then delete it. So I wanted to delete all the points it doesn't need after each iteration of the repeat zone, pretty much, right? So I'm going to include it in the repeat zone. So drag that in there, connect it up, and connect the output to the output, and drag this to the right. So now we have 200 control points. You see the difference? There we go. Quite easy, and we still have the same results. Beautiful. Now, the only thing we need to worry about is the actual array, of course. I just typed in a random value for the rotation. So if we have 12 iterations, then we need a 360 degrees is a full circle divided by 12, right? And we can actually crank down the iteration count by 1 because we already start off with 1 curve, right? That means we only need 11 iterations to end up with 12, right? That makes sense, I guess. And if we want to make this procedural, there's a very easy way to do that as well, and that is to drag out the rotation to Combine XYZ, right? The Z value was 30 degrees, but if I type in 30, it is going to mismatch. Reason why is because in the rotation we need degrees, and in vectors we use, well, radians pretty much, I guess, just random usual values. Now, if you had math, at some point people may have told you that a full circle is going to be 2 times pi, right? So we can type that in, 2 times pi, and that will be a full circle, right? So that's going to mean that we have this, well, we're rotating each iteration with a full circle, a full 360 degrees. That is not what we want. What we want is to have one value that controls the repeat zone iterations together with the rotation, right? So let's type in integer here, and we're going to set this to 12, right? So I want 12 segments, which means that I need 11 iterations. So I'm going to drag this out, math, subtract 1, all right? That means we're going to end up with 11. And for the actual degrees, I want to have this value, but I want a full circle to divide by 12. Excuse me. So what I want to do is type in search math, and I'm going to set this to divide, and the top value is going to be 2 times pi. Just type in pi, it works. And the bottom row is going to be this integer 12. And then connect that to the z value, and now we have a beautiful circle. And if I change this integer to higher values or lower values, you can see that it's going to stay procedural. Beautiful, isn't it? Right, so that's basically a little circular array that we just created, and it works quite nice. Now, if we want to create a branch out of this, all we need to do is hit Shift A and search for a curve to mesh once again. All right, and the profile curve is going to be, of course, a curved circle for now. Here we go, nice and big, crank down that radius. And we can now just give this radius specific to each point on the curve, right? So how far up or down it is on the curve, by simply adding Shift A. God, my keyboard is dying on me. Shift A and search a set curve radius. All right, so drag that in between, drag out the radius, and search for a spline parameter and a vector, right? So basically what this does is this little node defines the radius of a curve at a specific point in your geometry nodes, and your spline parameter, excuse me, is going to give it the input of which point your spline is, right? So a factor of 0 is at the bottom. It's going to mean that the radius is going to be 0. At the top, we have a factor of 1, which means the radius is going to be 1. Right, now we have one little spline that is actually in inverse, right? It's starting at 0, or sorry, at 1, and ending at 0. So what we do to fix that, right, and that is the only reason why this setup is a little bit annoying, is because we are merging a mesh and then we're converting it back to a curve. So Blender may lose a little bit of information it needs to specify what the starting point of a curve is and what the end point is, right? Luckily for us, there is, hit Shift A reverse curve node, right? And usually when you drag that in between here, it will fix that completely for you, right? So that is basically all we need to do. And now I want this, of course, to be the other way around. I want my branches to start thick and end small at the top. So to, to basically define that length, or to flip it around, we can hit Shift A and search for a float curve, right? And we can use the vector as the value, right? So now a factor of 0 is going to mean 0 because, well, our curve is at 0. And a factor of 1, the endpoint of the curve, is going to be 1 because this curve endpoint is at 1 as well. So if I now just drag this the other way around, it's going to swap out that direction. Right, quite easy. But that's not the only reason why we're using this float curve, because we could have done this on a different way as well. with a float curve, you can actually specify the full float of the curve, right? The full radius of the curve at any given point. Which means if I drag this point out, you can see that our thickness is going to, well, change with it as well, right? And if I change this to a lower, you can see that that point in the curve is getting thinner as well. Same thing here, right? We can create some weird looking shapes with that. And it's something I use a lot, something that is incredibly useful, right? So I'm going to Control Z that because I want something more like this. And if this is not thick enough for us, we can hit Shift A and search for an actual math node. Set that to multiply and just multiply all of these values by a specific value. For example, well, let's keep it at like this. Beautiful. All right, let's say we want a little bit of randomness here. It's very easy. We can hit Shift A and search for a noise texture, right? Noise texture is always what we need for randomness. It's the first thing that I add when I want anything to become random at all. And now we can hit Shift A and search for a set position. Right there. Now crank that color input into the offset. Hit Shift A and search for a vector math. Remember, anytime we use a noise texture to define an offset, we need to subtract a vector of 0.5. There we go. So it moves back to the center. And now we can, well, crank down that scale if we need. There we go. Or we can make it more strong by hitting Shift A, search for a vector math, and set this to scale. Right, if I crank up the scale, the noise texture will become stronger, pretty much, right? So, well, depends on what you need, pretty much. Now, there's one issue that usually occurs when we use the set position, and that is that also the origin points, the spawn points, right, the roots of our branches are also being displaced. And if you want that to stay in place, we can just multiply this offset with the factor, right? Because remember, the factor of a curve at its origin point is 0, right? That means that if we multiply that offset with 0, our offset is going to be 0 at that point, which means it's going to stay nicely in place. So let's just hit Shift A and search for a vector math once again. And we can set this to scale, and then we can swipe this vector into the scale there. Right, so now our start points are going to be nicely fixed at the same spot, and our endpoints will have the most kind of disformation. Right, so if I crank up the strength, you can see that our start point stays nicely in place, but the other points of our curve are going to be moving out a little bit. Right, something like this. Beautiful. Now, if this curve is too blocky for you, we can hit Shift A and we can search for a Set Spline Type. There we go. And we can actually set this to be NURBS, right? And then it will become nice and smooth. Beautiful. All right, so maybe this is a little bit too smooth though, because, well, let's be honest, what kind of branch is actually this smooth? Not a lot. So we can hit Shift A and search for our Resample Curve, and we can set this to a value that we actually want. All right, something like this perhaps. Beautiful. Now, if you want to give this a material, and that's the last thing I will do, but it's something that is quite hard to do if you're not really sure what to look for. If you want to give this a material, and let's say we want to give this a branch material, right, or a bark material, let's search for that. And this is Blender Kit, of course. You're familiar with it. I've explained it before. Let's say we want this to be a nice bark material, something like this, right, a willow bark. I can click on it. It's going to download 256 MBs for some reason. It's quite a large material. And it failed. Beautiful. So let's download this one instead. The oak bark. There we go. That works. And now to give that material to our bark, we just have to add one node at the end. Shift A, set material, and set this to be oak bark. Right now in rendered view, it's not going to look like bark whatsoever. So let's set our render to cycles and GPU. This does not look like bark, right? It just doesn't really look like bark. Well, there's one simple reason, and that is because our curve doesn't really have any type of UV map, right? You can see if I give this a different material that is going to be like blue, material 01, it will get the color, but it just doesn't know how to show this texture on this geometry. And that is usually the annoying part when you work with curves. But there's a very easy fix, right? And all you need to know is that a UV map is 2D. It has an X and a Y value, right? That is basically how it is going to be mapped. If I go to UV map here, you can see we have this square, 2D, an X value to the right and a Y value to the top. So what we need to unwrap this geometry is a vertical value and a horizontal value. Basically the tangent on the curve, right? The circumference in this case, because that is what we're giving it, right? We're giving this, where is that node? Where we go to a mesh, here we have a profile curve that is this circle. And this is basically our horizontal map, right? And the vertical map is going to be the entire curve, right? So how do we specify which parts of the curves go on which parts of the UV map? Well, very easy. We don't even have to unwrap this at all. All we need is a coordinate for the X and the Y direction. All right, so what we can do is at this point where we go to a mesh from a curve, we can hit Shift A and search for a capture attribute, right? And that is something we use when we want to save or forward an attribute from our mesh. And in this case, I want to forward the spline parameter once again. All right, spline parameter. The reason why is because I told you before, this factor of our curve specifies exactly at which point a point is in the curve, right? Bottom is 0, top is 1, and anything in between is anything in between, pretty much, right? So 0, 0.1, 0.2, 0.3, 0.4, blah, 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 up to 1. Right, so that already specifies the direction of the curve and already gives us a nice value for that direction of the UV map. All right, so that is all we need there. And for the curve circle, we actually need the exact same thing, right? So duplicate this. There we go, and swipe in the vector there as well, right? So because in the circle, the curve circle, we have the same vector, but then in the circular direction, right? The profile of this branch, right? So to combine this, all we need to do is drag this out into a Combine XYZ, right? Because after all, a UV map is a vector, right? It's vector information. So we need coordinates. So we have an X and a Y value. Z is not something we need, right? 2D. We don't need 3 dimensions. Now we want to store this. Shift A, search for a store names attribute there. And we want to store this as a vector, right? Because our UV map is a vector. Very, very easy. Now just crank the vector into the value and store this with a name that you can remember, right? So usually I do store UV. There we go. And then in our shader editor, we can locate the part that maps our texture. Usually there will be a mapping and a texture coordinate, and this is set to UV. Now, of course, the texture doesn't know that this is not the UV map that we want to use. We want to use this one, right? So let's delete this texture coordinate, hit Shift A and search for an attribute. There we go. Connect that up. And let's name this store UV, right? And right away you can see that we're getting a little texture that looks quite pretty at the same time, right? So let's zoom in. We can tweak the scale, make this all a little bit smaller, for example. We can tweak one direction. Let's see, something like this. I don't know what its texture is supposed to look like, but we can stretch it out a little bit. Something like this, right? So now we already have some kind of a bark. Add a quick environment texture. Whipple Creek Gazebo. There we go. We created a bark or a branch generator in, well, pretty fast actually, right? And we can tweak all these values. If we want more branches, just crank that value up, right? And if we want this to be a different kind of shape, for example, we want this to be wider, crank that out, make it longer. You know, it's completely procedural. It's geometry nodes. Do whatever you want with it. Amazing stuff. Amazing stuff. Right. So that's quite an easy tutorial, I guess, on how to make something procedural already with the repeat zone. As you can see, a repeat zone is, well, incredible. We can even rotate this around, make it wider, do whatever we need. Right. So I hope that helps. That is going to be it for this tutorial. Are there any questions about this?